Welcome back to PLS 510, Forage Management and Utilization. Today we're going to take up part 2 of Establishment Basics. During part 1 we covered matching forage to the site, soil fertility and fertilization, and variety selection. Now let's talk about seeding date and rate. There are optimum timing windows for seeding of forage crops that will depend on the species to be seeded, the availability of water, and your best guesses as to the weather that is coming. This is a artificially reproduced graph showing the probability of success for seeding, say, a cool season grass or alfalfa that has a spring and a fall seeding window. And the whole point of this is to say that even though we have very discrete windows for seeding dates, for example, in the spring the cutoff may end April 15, it doesn't mean that on April 16 that the chances of success go to zero. You've got, in fact, a bell-shaped curve for spring and fall seedings where you have a crop that can be seeded at either time. And whether or not and where you are on that curve even shifts left and right year in, year out. If we have a warm, dry spring, maybe this curve shifts to the left. If we have a cold, wet one, maybe the appropriate optimum dates move up to be the latter part of April. And similar things can happen in the fall. In general, when we're talking about cool season grasses and legumes, spring is better for legumes and fall is preferred for cool season grasses. For our warm season plants, then we're talking about something that is going to be a seeding date in the May or June range after the soil has become warm and we have gotten past the date of where we can expect a frost at some time. Let's talk a little bit about seeding rate, and the seeding rates are well established and they're published in AGR 18, but typically we want to make sure that we use enough seed in order that we can get a stand. And a lot of times it's not so much it is the absolute amount of seed, but you need to may make variations or changes in how you put that out. For example, if you're broadcasting tall fescue and the seeding rate's 20 pounds to the acre, then broadcast, one time, or if you get it uniform across the field and pack it in with a roller or however you're going to do it, and you're done. If you're drilling, because of putting so many seed in a row, you may choose, in fact, it'd be a good idea to seed that field in 2 different directions, but only put out half the seed each direction, so that you plant 10 pounds to the acre in one direction with the drill, and then come back and put 10 pounds in another. That cross-hatching drilling pattern is going to help you get full coverage faster. Plus, there is just a limitation in terms of how many seeds are going to germinate and do well in a row. So let's talk a little bit about seed treatments and coatings. And the reason why this is becoming so much more important, we've mentioned before that almost all of our legume seed is going to come commercially coated, and more of our grasses, particularly as some of them get in short supply, are going to come coated as well. Coated seeds are about 1/3 inert material that may contain fungicides, limestone, minerals, biologicals, and polymers, and various other things. They do help with inoculation of legumes. They do give us some treatment and protection against some fungal diseases, seedling diseases of plants. And sometimes they help make sure that you've got adequate water or hydration so that the seed doesn't germinate prematurely. They don't, now inoculum in and of itself doesn't add much weight, but the coating that you will find is about 1/3 of the weight in a bag of seed. These coatings are proprietary and they do change. Coated seed is denser and easier to broadcast. For example, that's a significant benefit for a species like crabgrass, which is so light and fluffy that is a little bit hard to broadcast if that's the way you're going to seed it. The coating does affect the flow through seeders, and it reinforces the need to calibrate the seeder. The example that I'm most familiar with actually happened to me. That if you think that coated seed is actually a larger seed, then you might think intuitively that you need to open up the seeder just a little bit in order to get the seeding rate correct. But in fact, the opposite is true. Coated seed flows faster through a drill than does uncoated seed for the most part. So back to the normal good practice when you're no-till drilling, and especially if you're using rental equipment, calibrate the drill for the seed lot that you're going to seed before you seed. In general, if you look at the research that's been done, coated and uncoated seed, seeded in equal amounts, pounds of material per acre, resulted in equivalent stand counts and equivalent yield. Now, there is one case where we do feel like you should make an adjustment in seeding rate based on seed coating, and that's with crabgrass, because coated crabgrass is oftentimes 50% coating. So we do feel like that you should make an adjustment in seeding rate when you're using or coated material to seed crabgrass. And to maybe just put this in perspective, genetics is the priority. If the variety that you want and that you need comes only coated, do not worry about it. Just get the variety you want. Seed at the recommended rate. For legumes, we do not typically recommend that you increase the seeding rate just because the seed is coated, and your stands will be fine. Let's move on to competition control and seedbed preparation, which I've lumped together because it has to do with getting ready to put the seed down. We do want to control weeds and control unwanted seed prior to seeding, and nowhere is this more important than when we're going to want to convert toxic tall fescue to non-toxic tall fescue in one season. In other words, from spring to fall. So if you begin in the spring, you're going to want to control seed heads in that tall fescue, the toxic tall fescue, so that you do not wind up having a bunch of toxic tall fescue seed laying on the soil surface that might germinate and contaminate your new stand of novel endophyte tall fescue, which of course is going to look almost identical and probably in most cases completely identical to the toxic tall fescue. If you want to think about land preparation, I think about it as how are we making the soil ready for the seed to be drilled into it or seeded onto it. Prepared seed bed is obviously one way to do it, although some of our sloping land in Kentucky, like the lower left, is not going to lend itself to prepared seed beds. But a prepared seed bed is obviously one way to get the seed bed ready, the land prep ready, and the seed ready, soil ready to apply seed or to put down the seed. Now, you can do no-till plus and minus herbicides. Obviously, the one on the left is with a herbicide, in this case a burn-down herbicide that's in Lincoln County. We can no-till things like clover into very overgrazed grass situations, and as long as we're prepared to control the grass growth is going to come faster than the clover seedlings, then we can make that work. And finally, the third instance I've got listed here has to do with sod disturbance, and that's with a chain drag here on the lower right. And the whole purpose of the chain drag is to disturb this thatch and layer of grass at the soil surface so that there is some bare dirt showing, so that this is typically in preparation or just ahead of a broadcast seeding of clover. So let's talk about the no-tilled and to kill sod. Of course, when we do this, then what we will follow with is a drilling with a no-till drill. Sod disturbance, on the other hand, is in preparation for frost seeding, in particular of clovers. And why do frost seedings work, and for what forages? Well, they work because they need bare ground and an external force to get seed soil contact, as opposed to the brilliant seeder and the cultipacking roller, or the no-till drill and its double disc openers and press wheels. In this case, we're using Mother Nature and this torn up sod to let the seed land on bare dirt. Now, we need some external force. Now, it can come from rain. It can actually come from hoof traffic. But oftentimes, or at least when we say frost seeding, we're thinking in the I guess the stereotypical sense of this honeycomb frost. And when you have bare dirt that's wet, or some bare dirt, and it's wet and it freezes, then the ice crystals that form, like these that you can see in the photograph in the lower right, will actually push up some soil particles. So if you were to broadcast on this, it's easy to see that the seed would fall down here in these lower areas. When this would then melt, when the sun comes up or it warms up, then those seed or the soil particles that are raised up on these ice crystals fall down and tend to cover the seed in a very shallow manner, which is just perfect. We can open up a sod by very close grazing and by chain dragging. The forages that this type of seeding method will work for are in particular clovers and annual aspidisa, but the ryegrasses can work too, in that they have such exceptional seedling vigor that they can then oftentimes catch if you are able, or establish if you're able to get it onto a bare soil situation like this. And it's important to realize that even when we have these species that seem to need very minimal work in order for them to come, that all of our establishment principles, all the basics that are in these last two lectures, they still apply. We oftentimes get the question, can broadcast alfalfa work? Red clover seed and alfalfa seed look pretty similar. And we know red clover can work by broadcasting onto sod or closely grazed sod or disturbed sod. What about alfalfa? Well, this is the yield from a study that we did in Owen County. In fact, that's where this picture was taken, from this study, and where we've compared alfalfa broadcast onto fescue, red clover broadcast, red clover and annual aspidisa or annual aspidisa alone, compared to fescue with nothing. And you can see that the alfalfa, there was some, but it was not much better than the fescue alone. The red clover and the annual aspidisa treatments were greatly superior in both legume content and annual yield. So let's move on to the seeding operation. And the whole goal, of course, of the seeding operation is to get good contact between the seed and the soil. And we most typically think of this with a no-till drill like this tie drill seen here. Now, it's important that we understand the drill adjustments that have to be made in order to get the depth right and to calibrate the drill. And those are going to be in the manual, and I would really, strongly suggest that you familiarize yourself with the manual before getting the drill. And most of the time when we find ourselves, unless you own the drill, most of the times it's a rental situation or a borrowed piece of equipment. And so it takes a little while for you to figure out how to adjust the drill, the depth, and the calibration. Now let's go back to the case of the brilliant seeder and the cultipacking roller. This type of seeding arrangement winds up with having ideal seed placement, but you have to have it on a prepared seed bed like the one you see in the upper left-hand corner, or actually on this slide in general. This is the same field, a close-up on the right, lower right, and you can see the small blue seed. This happens to be alfalfa seed that's dropped from the seeder right on top of the ground, and then those corrugated rollers coming through and pressing down. And what will happen is that most of the plants that germinate will appear to have germinated down here in this trench or this lower area where those cultipacking roller ridges ran and made this deeper groove. Depth is the biggest problem, I think, with no-till seedings, and that's and this is a case here in Fayette County, where we were seeding orchard grass and perennial ryegrass in the fall in a totally killed horse pasture setting. Now you see these cases where you've got green coming up in just real in rows spread out across the field. What you see is where the rows came up better under or behind the tractor wheels, and very poorly in this middle area. And the reason why is after we sprayed and killed this, the soil was so fluffy that this wound up being seeded much too deeply. But this, when the tractor tires rolled over it, it firmed it up and the seeding depth was about right. Now, in this case, had we done nothing more, we would have probably had a very spotty stand with a bunch of weeds. We would have had to have redone it. In point of fact, what we did after this was to take a chain drag and drag this whole entire field. And you can tell there's so little vegetation that what we ended up with was almost like a prepared seed bed. We then broadcast seed, and I took a corrugated roller and rolled this entire field. And the stands that we got were greatly superior to this. So no-till seed drilling depends on good seed placement. And when you do no-till drill, you should see some seed on top of the ground. And if you don't, either no seed is coming out at all or it's going much too deep. So I'm going to go back and reiterate the frost seeding method here, mainly just because I think it's that important to understand it, so that frost seedings work because we've got bare soil and an external force to get seed soil contact. Here are the forages that it works for, and this is a very effective way to get clovers into grass pastures, and even in some case to thicken them up with the ryegrasses. And the last point under this two-part establishment lecture is to do a good job with new stand management. And it only stands to reason that you've gone to this much trouble, all of these steps to get to this point. You don't want to mismanage this new stand and have to do this over. And I'd like to remind you that particularly for grasses, but legumes are not much different, you've got a very, very small seedling that you're trying to get up and to get big enough to withstand to be either harvested for hay or grazed or both. It's going to take some fertility. A lot of times we'll need to add some nitrogen to grasses or maybe some P and K for the seedling legumes. Will most likely need to do some version of weed control, whether it's to spray for broadleaf weeds, as in the case of grasses, or most oftentimes we will just mow, because if we've added clover to an existing grass stand, we will no doubt need to mow that stand to hold back the grasses or graze them very briefly in order to take off the grass, but not nibble down and get into the legume seedlings. We got to give it time. If we seed in the fall, then typically we'll want to take a first cutting of hay off of a cool season grass seeding and not pasture that until the end of that first summer, and even then we want to rotate. We don't want to take it too short. Grazing grasses too short compromises their lifespan, and nowhere is this more true than on a new seedling. And we also, again, want to manage competition by mowing or spraying. So I put this in because this is actually a field and a farm that I'm working with. This is a fall seeding of orchard grass, and this is a weed infestation that they have in a field that was actually taken out of a very rough pasture setting and trying to get it back into shape for a horse pasture. This happens to be poison hemlock, and it's in particular a very competitive weed in the wintertime because it gets very thick and it almost completely shades the soil surface. Our solution with this field is we are looking for that window of time here in the next, I'd say 2 to 4 weeks, where the weather is warm enough and dry enough that we can spray a broadleaf herbicide combination and to kill the poison hemlock and a couple of other weeds that are weed species that are present to release the grass. So the principle is to allow the new grass to get fully established before you put it back into full use. Okay, this is going to finish us up for this two-part lecture on establishment basics. Until next time, we'll see you then.